Okay, in this tutorial we're going to have a look at linear polynomial functions. Okay, so we're a little bit to talk about. Hopefully most of these ideas though is a little bit more revision, and hopefully you've seen them in previous years. Okay, so a general form for a linear function is y equals mx plus c, okay, where m is our gradient and c is our y-intercept. Okay, another often more useful form is our point gradient form. Okay, now we'll end up putting it in our general form most of the time, but this is a better one to work with when you're trying to find out what the equation of a line is. Because it's y minus y1, because m outside of x minus x1. So m is our gradient again, but we use this other point, x1, y1. Okay, so it's a very, very useful one. Okay, the gradient is equal to m, which equals rise over run, which is found mathematically going y2 minus y1 over x2 minus x1. So using 2 points, okay, and finding out the difference in change in vertical over change in horizontal. Okay. We can also say two lines are parallel if they have the same gradient, that is that m1 is equal to m2. Okay, so both our gradients are the same. Okay. If two lines have gradients such that m2 equals -1 on m1, then the lines are perpendicular. Okay, so if our second line has a gradient that's -1 over our first gradient, then the lines are going to be perpendicular. Okay. The midpoint of a line segment is found at x1 plus x2 on 2, y1 plus y2 on 2. Okay, so all that means, okay, is that we're going to average our two x values, average our two y values, and we're going to get a point in these are the midpoint. Okay. Also, the length of a line segment is found using this formula, d equals the square root of x2 take x1 squared plus y2 take y1 squared. Okay, this is also known as the distance between 2 points equation. Okay, and really it's just Pythagoras' theorem. Okay, the last bit that we need to have a look at in terms of our theory, okay, is the angle made by a straight line and the positive x-axis, so actually is found by theta equals inverse tan of m. Okay, so we're going to take the inverse tan of our gradient, we're going to get the angle it makes with the positive x-axis. Okay, so we're going to have a bit of a look here. Okay, at a bit of an example. Okay, so I've got a straight line here. Okay, we can see their endpoints are at -3, 4 and 2, -6. Okay, and our equation is y equals -2x take 2. Okay, and we've got a few things that we need to do. Okay, so the first thing that we need to do is find the length of the line. Okay, so the length of the line, okay, is going to be our distance between 2 points. Okay, so we're going to go the square root. Okay, now we need to go x2. Now remember, x2 is always the bigger value. Okay, so we go 2 minus -3 squared, okay, plus y2, now that's always the one that corresponds with our x2, that's going to be -6 take 4. Okay, so you can see there, that's going to equal, well, we've got the square root of 2 take -3 is 5, squared is 25, okay, -6 take 4 is -10, so that should be squared. It's going to give us 100. It's going to be looking at the square root of 125. Okay, and I forgot to work this out before we did this, but it's going to be a little bit bigger than 11, probably somewhere like 11.07. Okay, you can check that on your calculator later and see how good I am. Okay, see if I'm anywhere near it. Okay, the next part is finding the midpoint of our line. So our midpoint was nice and easy. That was just averaging our x and y's. Okay, so I've got -3 plus 2 on 2, and we're going to have 4 take 6 on 2, okay, which is going to give us -3 plus 2 is -1. Okay, so it's going to be -1 on 2, or -1/2. Okay, and 4 take 6 is -2. Okay, on 2 is going to give us -1. So our midpoint is going to create -1/2, -1. Okay, it's going to be in here somewhere. Okay, midpoint's going to be right in about there. Okay, now we also want to find the angle the line makes with the positive x-axis. Okay, so remember our angle it's going to equal inverse tan, right, of our gradient. That's going to be inverse tan, right, of minus 2. Right, now when you do that, right, you're going to get, I think it was minus 63 point something or other. Okay, now you need to think about what that actually means. Okay, and that is really, it's our calculator is spitting out this angle in here. Okay, and it's saying that that is our 63 point whatever it was. Okay, or depending on the question, you need to be a little bit careful. Okay, because it might specify the angle up here. Okay, so you need to realise, well, that's not going to be negative 63, and you can't just change the sign and say it's positive. Okay, that one actually works out to be like 116.56. Okay, sorry, so that must have been 44. Okay, so that's what we're looking at there. So you just need to be a little bit mindful of exactly where our angle is, okay, and what it means. Okay, so negative angle, it's like our trig, it's going to be measured back this way, so below that x-axis, not above it. Okay, find an equation of another line that would be at right angles to this line. Okay, so we know that our second one, m2, has to equal, our gradient, or our other line, has to equal negative 1 over m1. Okay, well, what was m1? We know from our equation it's minus 2. Okay, so that means our other gradient has to be positive 1/2. Now at this point we can basically make up almost any y value, because we know we're going to be y equals 1/2 x. Okay, now be really careful here though, because if you happen to go too high, okay, if you said 10, okay, you're actually not going to be perpendicular because of the endpoints here. Okay, most of the time though you're going to be talking about a line that goes on forever. Okay, so let's just say for argument's sake we make it plus 1. Okay, we know it's not going to be an issue, it's 1/2. Okay, plus 1, it's going to run through there somewhere and not give us any issues at all. Okay. So that's just a few different types of questions and skills that hopefully are a little bit more of a refresher than anything brand new, though you may not have seen this idea before. Okay, but yeah, hopefully that's enough to get you through some of your work.